The very first thing a network learns is where the edges are. A convolution kernel slides across the image, multiplying values and producing numbers that reveal boundaries. Horizontal edges, vertical edges, diagonal edges. Dozens of detectors emerge. Nobody told the network what edges are. It discovered them because edges are the most useful first feature for understanding any image. On the left, raw pixels. On the right, the edge map. From noise to structure, Layer 1 discovers edges. The first step from raw numbers to real understanding. You see a face. A machine sees numbers. What a computer actually receives when you show it an image is not shapes, not colors, not meaning, just a grid. Each square is a pixel, a single number between 0 and 10^55. To the machine, there is no difference between a pixel in a face and a pixel in a brick wall. They're all just numbers. The machine has no idea what it's looking at. So how does it ever learn to see? Raw pixels are meaningless. The journey from numbers to understanding starts now. Edges are just the beginning. Watch what happens when they combine. 3 edges feed into the second layer, and textures emerge. Grids, corners, curves. None of these exist in the original pixels. The network built them by combining simpler features. Layer 1 found edges. Layer 2 found relationships between edges. Complexity builds from simplicity. Layer 2, edges become textures. Each layer sees something the last one couldn't. 5 layers, 5 levels of understanding. Pixels become edges, edges become textures, textures become parts, parts become objects. A particle enters as raw pixel data, gray and formless. At layer 2 it turns green, edges. At layer 3, gold, textures. At layer 4, purple, parts. At layer 5, red, objects. Each layer adds meaning. Deep networks build understanding layer by layer, from pixels to concepts. Inside the network lives a hidden universe, the embedding space. Every piece of data gets a position in it. Before training, it's chaos, cats next to cars, birds mixed with fish. But as training begins, dots migrate. By epoch 100, clusters form, cats with cats, dogs with dogs, cars with cars. The network discovered that these things belong together purely from the data. The embedding space is where the network stores its understanding. Watch, similar things find each other. 60 data points, 5 classes. At epoch 0, accuracy is 20%. By epoch 1000, clear groups emerge. By epoch 100, 5 crisp clusters, and 1% accuracy. Training doesn't rewrite the network each step. It gradually pulls similar representations together and pushes different ones apart. Training is learning to group similar things in embedding space. 700 EIG HTY for your dimensions down to 2. Tigluntag HT by 10 large image has 700 EIG HTY for your pixels. Too many. So the network compresses. A funnel squeezes them. Tiglu 5 to SIX, SIXTY for your 16, 2. The entire image captured into numbers. Low dimensions make data easier to work with and easier to visualize. Push too far, and you lose subtle differences. Representation learning finds the smallest space that preserves meaning. Train once, use everywhere. A A5V network trained on millions of images learns universal features. Edges, textures, parts, objects. Freeze those layers. Only the last layer learns. New task, classifying flowers. The frozen layers extract features they already know. The last layer learns roses and daisies. Training from scratch needs 1,000,000 images and days of work. Transfer learning needs 100 images and minutes. Don't reinvent edges. Reuse what others already learned. Not all pixels matter equally. Attention learns a heat map. Bright gold means look here. Dark means ignore this. The network decides where to focus. Without attention, every pixel gets equal weight and accuracy stalls. With attention, the subject is amplified, background suppressed. Accuracy jumps. Attention teaches the network where to look, not just what to see. From raw pixels to understanding, watch the full journey. Pixels become edges, edges become textures, textures become parts, parts become embeddings. Attention focuses the signal, classification makes the final call. A particle enters as gray pixel data, green at edges, gold at textures, purple at parts, blue in embedding space, gold under attention. Finally, a green flash, classified. The machine knows what it's looking at. NINIT-50s, HNDC RFTD features, brittle rules, 60% accuracy. T-Blue anti-Y for you are. Learn representations, transfer learning, attention, NINIT-Y 90% accuracy. Representation learning, machines that teach themselves how to see. From pixels to understanding, the deepest magic in all of AI.